Chapter 2, Section 5 is on the applications of the equations of kinematics. Now, kinematics can be applied to any moving object as long as the acceleration is constant. And each equation contains 4 variables, but in order for the equation to work, you must have 3 of the 4 variables in order to find the missing one. Also, you need to decide which directions are to be called positive and negative relative to the coordinate origin. And what I mean by that is I have a coordinate plane drawn over to the right in orange, and north is positive, east is positive, south is negative, and west is negative. And what this is going to be used for is to figure out the direction of displacement, acceleration, and velocity, because they are vectors, so the directions do need to be taken into account. Also, decelerating and deceleration, they're very similar but slightly different. Decelerating is the acceleration vector points opposite the velocity vector. And the only difference between decelerating and deceleration is that in deceleration you do not know which direction the velocity vector is pointing in. So both of them have an opposite pointing acceleration and velocity vector. You just don't know which direction the velocity vector is pointing in deceleration. So a problem you would see is a jetliner traveling northward, which means it's positive in relation to the coordinate plane we saw on the previous slide, is landing with a speed of 69 meters per second. Once the jet touches down, it has a 750 meter runway in which to reduce its speed to 6.1 meters per second. Compute the average acceleration, magnitude, and direction of the plane during landing. So write down everything you know. Your initial velocity is 69 meters per second. The track is 750 meters. Your final velocity is 6.1 meters per second. What is your average acceleration? So you'd use the equation v final squared equals v initial squared plus 2ax. So you'd plug in 6.1 squared equals 69 squared plus 2a times 750. So you get 37.21 equals 4,761 minus 1,500a. Then you get negative 4,723.79 equals negative 1,500a. And a equals 3.1 meters per second squared. And since it was decelerating, it is going northward. It's going southward because it is decelerating. It went from a speed of 69 meters per second to a speed of 6.1 meters per second, so it is going southward. Another problem is a cart is driven by a large propeller or fan, which can accelerate or decelerate the cart. The cart starts out at the position of x equals 0 meters with an initial velocity of positive 5 meters per second, and a constant acceleration due to the fan. The direction to the right is positive. The cart reaches a maximum position of x equals 12.5 meters, which it begins to travel in a negative direction. Find the acceleration of the cart. So your initial displacement is 0 meters. Your initial velocity is positive 5 meters per second. You have a constant acceleration. Your final displacement is positive 12.5 meters. So you'd use the equation v final squared equals v initial squared plus 2ax. So you use 0 squared because since it's going in the opposite direction, it will eventually slow down and come to a stop. So its final velocity will be 0, equals 5 squared, which is your initial velocity, plus 2a times 12.5. So you get 0 equals 25 plus 25a. You subtract over the 25, so you get negative 25 equals 25a, and you divide by 25, so your acceleration is negative 1 meter per second squared.